Hello, this is Mrs. Taylor, and I'm going to go over number 16 and 17 from the study guide for exponential functions. So number 16, you buy a new computer for $1,700. The computer decreases by 40% annually. In how many years will the computer have a value of $700? So when we were looking at this graphic organizer in class, we were given a general model for exponential growth and exponential decay. And if you read through this, you see that keyword decreases, which means this would be an exponential decay. And so my general formula for setting up my model would be y equals a times 1 minus r to the t power. And if you look, A is your original amount, R is your rate, and T is your time. So if I look at this scenario, my original amount was $1,700. My rate was 40%, and remember when we enter rate, we do that in decimal form. So it'd be 0.40. And then T is your time, and that changes, so we leave that as a variable. Now, in this scenario, they want to know when the computer will have a value of $700. $700 is not a measurement of time, it's actually your amount. So what you're solving for this problem actually looks like this. Now, when we've had growth and decay problems that we're looking for where the y value equals a certain amount, what we've done is we've used the table function in the calculator. So what you do is you go to y equals and you type in your model, so 1700 parentheses 1 minus 0.40 and then to the x power. And then I will look at the table, and what I'm looking for is when y is 700. So looking over here in this column, it goes from 1020 to 612 between x equaling 1 and 2. So this value of this computer happens somewhere between the first and the second year. So I could write between 1 and 2 years. So some point in between that first and second year, that's when that computer will have the value of 700. So that's how you do number 16. Now, number 17 switches topics on you. Number 17 is asking average rate of change. And what we've discussed in class is the average rate of change is just using the slope formula to find the slope between 2 points. So even though we know this line is a curve and we know that its slope is constantly changing, the rise over the run goes from less steep to more steep, we can find the average slope between 2 points just to get an idea of what the rate of change might be on that interval. So here it says from x equals -2 to x equals 2. So if I'm supposed to use the slope formula, I have my x's, they gave those, but I need my y's. So the way I find the corresponding y values is I take these x values and substitute them into my equation. So I need to substitute -2 for x. And remember function notation. This shows that my input will be -2. And I write that out with -2 substituted in to the x's place. And then I can use my calculator to evaluate that if I'm not confident with negative exponents. So that would look like that, and it gives me -1. So that means your first point is -2, -1. Now we're going to repeat that process, but for when x equals 2. So I substitute 2 for x. I'm going to type that in my calculator, and I get -81. So that means my second point, its coordinates is 2, -81. Now I have something familiar to use to find my average rate of change. It's in a format that's familiar to me. So y2 minus y1 would be negative 81 minus negative 1. X2 minus x1, 2 minus negative 2. Minus the negative becomes plus, so negative 81 plus 1 is negative 80. And then 2 minus negative 2 becomes plus, so that would be 2 plus 2, which is 4. And divide that out and you get negative 20. So my average rate of change for this curve from negative 2 to 2 is negative 20. And that's how you do 16 and 17 on the study guide.